So our next panel, looks like we've got them all here, is about lunar surface operations. It's a discussion on lunar surface operations. And I'm hoping that after we hear this discussion, your thoughts about lunar surface operations will not be what you saw at the end of Space Cowboys with Tommy Lee Jones sitting there just looking up at the Earth. Lots of more things to do there. We've got Rob Chambers from Lockheed Martin, Clive Neal from the University of Notre Dame, and Harrison Schmitt from New Mexico. And Dr. Alton Kirk will give the introductions.
Well, thank you very much. Yes, I'll introduce the three panelists. First is Dr. Harrison Schmitt. Senator Harrison Schmitt was born in New Mexico, grew up in the American West. He received a Bachelor of Science from Caltech and a PhD in geology from Harvard, based on work in Norway as a Fulbright Scholar, National Science Foundation postdoctorate fellow. Selected by NASA as a scientist astronaut in 1965, he flew in space as Apollo 17's lunar module pilot, landing on the moon's Valley of Taurus Littrow, December 11, 1972. He's the only scientist and the last of 12 humans to step on the moon. Elected to the U.S. Senate from New Mexico in 1976, Schmitt worked on legislation and New Mexico affairs related to technology, immigration, education, healthcare, commerce, and national security. He also served on President Reagan's Foreign Intelligence Advisory Board, Army Science Board, and President H.W. Bush's Ethics Commission. And from 2005 to 2008, he chaired the NASA Advisory Council. He's received numerous honorary degrees from the U.S. and Canadian universities, serves as an associate fellow at the University of Wisconsin-Madison, and he has served on the board of a number of corporations. So let's welcome Harrison Schmitt. Dr. Clive Neal grew up and was educated in the United Kingdom, where he earned his PhD in geochemistry and petrology. He spent 4 years as a postdoctoral research fellow at the University of Tennessee, Knoxville, while he studied mantle petrology and was introduced to the study of Apollo lunar samples. Neal has been involved in a study of the moon since Apollo samples and remotely sensed data from later missions. He's currently a professor of lunar geology at the University of Notre Dame. Neal has served on numerous panels throughout his career, including service as the chair of the Lunar Sample Allocation Subcommittee, chair of the Senior Review Panel for NASA's Planetary Science Division, and chair of NASA's Lunar Exploration Analysis Group. In 2015, Dr. Neal received the Wargo Award for contributions to the integration and exploration in planetary science throughout his career. So let's welcome Clive Neal. Rob Chambers. Rob Chambers is the Director of Human Spaceflight Strategy and Business Development for Lockheed Martin Corporation's Space Systems Company. In this role, he's focused on Lockheed Martin's blueprint for deep space exploration, leveraging the company's proven heritage in robotic and human spaceflight to extend humanity's understanding of our solar system to answer fundamental questions about where we come from, where we're going, and whether we're alone in the universe. Rob has been with Lockheed Martin since 1993 and has worked on a variety of space systems company programs, including Earth remote sensing satellites, Space Shuttle, Orion, and deep space habitats. Throughout his career, Rob has led the development of guidance and control subsystems, avionics, and flight software. Rob earned a bachelor's degree, master's degree in aeronautical and astronautical engineering from that world-famous Purdue University. So let's welcome Rob Chambers. let me start with an issue of prioritization of landing sites. As a little background, the Apollo missions all landed on the near side of the moon, near the equator. Humans have not yet landed near the lunar poles, where scientists could study lunar ice, or on the far side of the moon, which has command and control challenges associated with a lack of a direct line of sight between the far side and Earth. Now, with Harrison stepping on the moon, I'm going to ask him to entertain this question for us. So how would you prioritize sites for lunar bases for robotic exploration sites, and why?
The primary motivation for going into space is probably not so much where you land on the moon or on Mars, but it's geopolitical, and we can talk about that some more later. Science has benefited tremendously from our understanding of the moon. Primarily, it has led to an understanding of the Earth that we did not have and could almost certainly not have obtained without our knowledge now of the moon. The moon has told us about the early environment of the solar system, in which not only did the Earth evolve and accrete, but also the environment in which life evolved here on this Earth. So science generally has been a great beneficiary of the geopolitical impetus to not only go into space with Apollo, but also to continue the programs that you heard about earlier today. Now, as far as landing sites, we really had the capability in Apollo, had we continued that program, to land on the far side of the moon. Communication satellites in the libration point behind the moon would have provided communications with the Earth if you felt that was necessary. I'm not sure all the astronauts felt that was necessary, but nevertheless, it did help a great deal in the exploration program. We actually, a small group of colleagues at Johnson Space Center and I did explore and define a method by which you could have landed in Tsiolkovsky, for example. We had the photographic coverage and the operational information we needed in order to land there. It was not really something that NASA wanted to do at the time, however, becoming increasingly conservative and interested also in the space shuttle program. Now, though, I think that the highest priority scientific landing area would be South Pole Aiken, the very large basin, some 2,500 kilometers in diameter, that on the far side of the moon, that has a great deal to tell us, I think, about the internal structure of the moon as well as its early evolution. And again, that evolution involved on Earth the beginnings of the organization of complex molecules that ultimately became replicating organic molecules. However, when you look at the broader context of our future in space, including going on to Mars, and Clive is going to talk about this in much more detail than I will, I think, the need for lunar resources is going to be absolutely critical. People often ask, well, why is the moon in the path to go to Mars? It's one of the main reasons is we need its resources. We need its water for radiation protection as well as life support. We need its oxygen for life support as well as propulsion, along with hydrogen and potentially methane, depending on how that trade study goes. You have to begin to think very seriously about how do we establish the capability to produce these kind of resources in quantity from the lunar regolith, potentially from the poles. Again, that's another trade study that has not been completed. And when you start to balance science with the need for those resources to continue the geopolitical objectives of being in deep space, that's going to, I think, produce some very interesting debates. And with that, I'm going to pass it on to others.
Let me give Rob a related issue, which is a balance between robotic and human exploration of the surface. During the Apollo mission, robotic missions first mapped the lunar surface and performed initial scientific studies prior to human arrival. Robotic missions are less costly than human missions, don't endanger lives, can deliver supplies in preparation for human missions. But humans learn quickly from their environment. They can apply knowledge, they can adapt, make adjustments. So given the current state of technology, humans can perform more complex tasks, including habitat construction and advanced scientific experiments. So what do you think is the right mix between human and robotic exploration of the lunar surface?
Yeah, that's a really great question. From a Lockheed Martin standpoint, science is in our DNA. We've had the fortune to be on all of the Mars missions, partnered with NASA in one capacity or another, and to all the planets, even the things that were planets that may not be planets now. And it's always been, those are robotic missions, obviously. Our feel is that the combination of humans and robots give a lot more than the sum of their parts. And a little bit specifically, in looking forward, one of the things, there's so many fantastic things going on, piece parts associated with exploration today. One of the things that we've been looking very closely at with our PI colleagues and the scientists is what do they need from an overall architecture, sort of that story arc from here to the surface of Mars. And one of those key stepping stones, I used it. I promised I wasn't going to say stepping stones, Clive. One of the key elements of the architecture is the high ground. With humans in Mars orbit or in lunar orbit, the ability now with very, very high bandwidth, low latency, which is a bigger deal, of course, at Mars than exploring the moon. Humans in orbit, you've got unprecedented ability to collaborate and integrate with the robotics that are the surface elements. And so our view, my personal view, the robots are the vanguards. We need the robotic prospectors to go find the fuel in the form of water for hydrogen and oxygen, for eclipse and for propellant. We need to find the volatiles and whatever products, frankly, are going to come back from the moon beyond fueling the next stage of exploration. But with humans in the loop, whether they're in lunar orbit or ultimately then in certain spots where we want what some of us call ground truth, working hand in hand, or hand in wheel next to the rovers on the surface, at those key spots that the initial robotic explorers have pointed out for us. That's where you get that symbiosis between the robots and the humans. So you need both, ultimately. And of course, what NASA's doing right now with the gateway to provide an infrastructure for those robotic elements, be it communications, power, any of those others that reduces the barrier of entry to get robotic payloads onto the surface, followed then by reusable systems like the one that we might talk a little bit about today. That's our concept, similar to some of the other engineers out there. To get the humans down, we'll then be able to get that ground truth alongside the robots. So we're going to need both.
Could I jump in on that one?
Briefly.
As a field geologist, I think I would look at it somewhat more differently. I think robotics are extraordinarily useful tools. They can be precursors, as was described, to identify the targets for human exploration at the surface. And they can be postcursors because you're never going to have enough time to do everything that you want to do. And I can even, for Taurus Littoral, where I work for 3 days, I have all sorts of places I'd like to send a postcursor robot to gather some additional information. But I think you can't underestimate the value of extended human exploration. It's not just ground truth. It's extended exploration of finding new things that robots just won't find. You cannot program a robot to do anything other than what you program it to do. And human beings can reprogram themselves instantaneously based on experience, on knowledge, and what Gene Shoemaker used to call perspicacity, and said that was an essential ingredient to any exploration on the moon. So I would be very careful in thinking that somehow or another remote or telerobotic actions by humans are going to substitute for actual on-the-ground exploration with the human eyes, the human hands, and the human brain integrating what you're going to see and find, and the discoveries. Apollo 17 was a classic example of discoveries that we never expected to make, and would not have made almost certainly without humans being on the ground.
I think the next topic is right up Clive's alley. Lunar samples, such as rocks, dust, and ice, exist in an environment free of contamination from humans or the Earth's environment. Once such samples are collected, they may require multiple types of analysis. Designing and launching scientific instruments to the lunar surface for complex sample analysis can be costly, but transporting them back to Earth with minimal changes or contamination due to heat, light, radiation, oxygen, biological contaminants is challenging as well. So Clive, can you talk about the best practices for analyzing lunar samples? Should they be with instruments in situ, within the lunar environment, or collected and transported back to Earth for scientific analysis?
Okay, I want to, just before I answer that one, is come back to the landing site issue, and the question for everybody here is, why are we going forward to the moon? That will determine what your landing site is going to be and the samples that you'll be looking for, because as Rob used the term stepping stone, and I bloody hate the term stepping stone, because you abandon everything that you've built up and got there, and we don't need to do that. So why are we going forward to the moon becomes an important question to determine the site, and then the types of activities that go on the surface, whether it be resource prospecting with robots, which is going to be essential for developing the lunar economy and involvement of private sector. And then it also is important for the return of samples, because it depends upon the type of sample you want to bring back. If it's a basalt, or basalt, if you have an accent, you pick it up, you put it in a bag, you vacuum seal it, you bring it back. We know how to look after moon rocks. We've had a few years' experience, even in the not very humid climate of Houston. We know how to keep the Apollo samples pristine for the most part. But if you brought back a sample of the water ice that we now know is present at the surface of some of these permanently shadowed craters, maybe up to 38% water ice, you wanted to bring that back, then you've got a challenge, because that's been around temperatures of less than 100 Kelvin for maybe millennia and beyond. We don't know. But you want to try and keep that pristine. It's probably not worth the effort to bring it back, so you need some sort of in situ instrument to be able to do that. If you're going to do exploration and bring back regolith, we now know that there's a lot of loosely held volatiles in the regolith, so we need to vacuum seal those types of samples. And believe it or not, there are core tubes of Apollo samples that were vacuum sealed and have not yet been opened. So, well, they were sealed on the moon, let's put it that way. And there's now a project out there to look at these with the view of developing new sampling techniques to actually capture the volatiles that have become front and center in the way that we now view the moon. This is a whole new moon based upon the samples that have been brought back. You look at the glasses that Jack collected, 74220. That's a start. And around from Shorty Crater. It wasn't until 2008, it was collected in 72, 2008, that it was definitively shown that there was a diffusion profile of water out of these glasses. So 36 years. You bring the samples back, they are the gift that keeps on giving, whereas if you just analyze them on the surface and your robot dies, you're done. So I wouldn't have a career if we just did that with Apollo. So thanks very much, by the way. So
I should just interject, the advance of analytical technology is what enables these kind of things to happen and to continue to happen, and they will, as Clive has indicated.
yes, sampling, bringing samples back is important for also training the next generation. We've heard about that with engineering, but it's also important for the science aspect to have young people. I can't use the term kids, right? That's an, can't say young?
Early professional.
Oh my God. This is why I don't work for the government. All right. So we have to train the next generation of people, early people, all right? But if we've got the samples in hand, and you can definitively show this comes, or you know it comes from another planet, that's inspirational. So you can inspire the young by just showing them and get them interested. Well, how do I become involved with that? Well, become a geologist. That's the way I did it, but it's and the way Jack did it. But that's a long-winded answer.
So the next topic, I think, is important in these day and times, and let me ask each one of the panelists to touch on it briefly. We'll start with Rob and come this way. It has to do with international cooperation. Human missions to the moon can be expensive. These missions perhaps could be made more affordable by leveraging the contribution of financial resources from multiple nations. So the question is, if the initial human missions to the moon's surface are accomplished through international cooperation and shared contributions of financial resources from multiple nations, what might be the best way to determine the level of in-person participation for each nation in lunar surface operations?
Yeah, that's an interesting question. We look at it. I look at it from the perspective that we are really at the precipice of expanding human presence and exploration with robots and humans out into the solar system at any other time. Probably, other than Apollo, we've never marshaled the technology, the know-how, the political will, and the interest of the public and of the government. What's interesting this time, of course, is that there are international players. We're not doing it in the eyes of the world. We're doing it leading the world with their help. And with critical contributions they're making already. You heard my boss, Mike Hawes, talk about the European Service Module, which is how the capsule and all the spacecraft elements get out there, circularize, and come back. And so I think that trend is going to continue as we look at the gateway, which we'll probably have a little discussion about, I'm sure, as we move through this. That's a great opportunity for the internationals to contribute everything from labs to habitats to test data to onboard processing to be able to handle that kind of in situ science that we're going to need to do with the early career professionals. The question then becomes, is it a contribution role with an occasional international astronaut that's going and participating down on the surface? Or is it a true partnership where different agencies are making use of, for example, the gateway for surface access? And that's what's really fascinating to see how that's going to play out. Once you have that infrastructure in place and you've lowered the barrier of entry for access to the surface in terms of communications, power, propulsion, fuel, if you want to stop off at the gateway, and sample return opportunities, it really opens up the trade space and opens up the exploration space for internationals. So we're very much, exploring the solar system is by definition a global activity. Jack could probably speak to that more personally than I could, but as soon as you have left the Earth, you are representing humankind. And as we explore out into the solar system, it's going to be a joint venture bigger than one company in one country. It's a global activity.
I think we have a model for doing this with ISS. I know Tim Peake was up there from the UK. Huge press coverage and a lot of publicity about that back in the UK. That's before we left Europe. We won't talk about that. But I think you've got to build that integrated approach to it. ISS is maybe a way forward. But it depends on how much America wants to lead. It's talking about leading the world back to the space, but that back into beyond low Earth orbit. But we did that. We said that in Constellation, and then we did a bait and switch. And I don't think that can happen again, or should happen again, because the credibility will be gone. And if you want to develop international cooperation, you can't bait and switch like that, because the partners will just not believe you anymore. So if you look at ESA, has got a bilateral partnership with Russia. Russia and China have got bilaterals. There's international cooperation going on because they haven't broken their promise yet. Maybe I shouldn't have said that, but I'm going to say it. But it's, I think it's important to have believability in the international community that this is the path, but that's a political path. And so to get that right balance, it needs to be a long-term plan that doesn't change.
I may be odd man out here. I think we're in another Cold War geopolitical situation, and the Vice President has indicated that, and the President indirectly has as well. That has been obvious to some for a couple decades. And when I went into space and when the Apollo astronauts went into space, we were representing the United States. That was a geopolitical program, and you have to realize that. Sure, humankind benefited from it, but nevertheless, they also benefited from its geopolitical consequences. The effort that we're about now, I think, has to be viewed in the same context. And in that context, as with Apollo, you can have international cooperation. Commercial entities made Apollo possible. They were the contractors. And all of that can go, is very, very important for success. But you cannot have, I think, international groups in the critical path to success. You've already experienced delays on Orion because of that. And I just think that if you really believe that this is a geopolitical effort, then the United States has to be responsible for the critical path to success. There can be partnerships peripheral to that, but as there were in Apollo, for example, the lunar sample analysis was an international program. Thanks to Gene Shoemaker's initiative, there were, in the initial analysis teams, there were 4 international groups that did remarkable work on the early lunar samples. But if you start to proliferate your critical path dependency, it ain't going to happen. This is going to die just like Constellation did.
Harrison mentioned commercial entities briefly. So I want to ask him to start off with this one, and Rob and Clive can chime in later. Elon Musk of SpaceX and Jeff Bezos of Blue Origin are just 2 examples of private industry leaders who have commented on plans for landing on the lunar surface. Unlike the Apollo era, these 2 companies in particular are active in the launch market, and they're aggressively pursuing plans for large launch vehicles, and they have access to non-traditional sources of capital. So Harrison, could you discuss the appropriate role of commercial entities in the next phase of lunar surface exploration? Is there a role? If so, is it limited to launch, landing services, or is it the commercial exploitation of lunar resources in the near-term horizon? Are there any legal barriers that currently discourage the commercial use of lunar resources?
Well, I think that having come out of the corporate world myself for many years, that decision is going to be made within the corporate environment of whether there is a business case for such involvement. And I can't analyze the business cases for these various corporations, but obviously they seem to think that there is a business case in the long run. And it has to be looked at in the long run. I don't think there's a short-term profit issue, but there certainly are potential very high long-term profits, particularly as you referenced in the development of lunar resources. I would say that any future combined plan for the indefinite occupation and exploration of deep space should assume that the development of lunar resources is probably going to be a private sector led effort. Now, will they use the low-cost SLS system of the future in order to get there? That's a trade, again, that has to be made by these companies. Or will they build their own rocket system, as I suggested in the book that I wrote, Return to the Moon? Nevertheless, I think the resource development and production is clearly made to order for private sector activity. But the geopolitical aspect of this really has to be led, I think, by the United States government, and that will play out as we see. Now, with respect to the legal aspect of this, my own interpretation of the Outer Space Treaty of 1967 is that as long as a private entity is, shall we say, licensed or authorized by a signatory to that treaty, they can make use of the resources of outer space. The one thing that is missing, I think, and should be developed and led by the United States is the creation of a regime of claims, a claim regime for the moon, so that is organized and managed by, if not a full international group, at least by a variety of nations that may be spacefaring nations and may have an interest ultimately in lunar resources. There is a precedent for doing that, and that is in the United States response and their allies' response to the Law of the Sea Convention, in that there is an agreement between a number of nations to recognize each other's claims to deep sea resources. Now, that hasn't really matured in any significant way yet, but that is a precedent. Unfortunately, that was eliminated from the Antarctic Treaty during its early years, and so the Antarctic is exposed to somebody opting out of the Antarctic Treaty and exploiting resources that they find in Antarctica. That is a big problem within that Antarctic regime. Nevertheless, I think that the United States could lead the effort in creating that claim regime, and again, I've described a possible one in that book that I mentioned earlier. So yes, I think private sector is probably they're probably still trying to define the business case for activities in space, and I'm not sure that they have really yet fully matured what that business case may be.
Rob, Clive?
Good. Yeah, if we bring up my package, there's a couple of relevant slides. So the current member of a publicly traded commercial space company on the panel, when we will look at the slide, we kind of view it as a multi-phase from our perspective. There is an early phase where government can, and this is the whole commercialization writ large, where it's truly just privatized commercial services for the government. The government is the only customer. You're not selling to anybody else, and you're doing some form of investment, and you are then getting some return, and you're making a profit. We've been doing public-private partnerships for 40 years now. If you've heard of IRAD and government, even fixed-price contracts where you have to put in that early investment. So this is nothing new. Those privatized commercial services for the government, like commercial cargo, for example, or definitely commercial crew, those are valuable where the government can push down some of the management, the day-to-day execution, if the technology is really, really well understood. Returning from low Earth orbit is not safe, and I'm not sure I'd ever call it safe, but it's pretty well understood and characterized. And so the engineering solutions that, for example, we are using, both taking from Apollo or from Orion, are being obviously provided over to the commercial crew folks to improve and to leverage for their systems. So that's very logical, but that's not necessarily an economic endeavor. When you talk about cislunar space and it's a moon-Earth economy, there's no lunar economy unless there's like some rich alien on the far side. There's not a lunar economy, it's an Earth-Moon economy. So you need to find what are the things that the Earthlings will pay for beyond just our governments, who are also Earthlings. But we're talking about like Clive. How can I get Clive to kick in? And it might be from his cell phone service. If he's paying for infrastructure, which includes the ability to have spacecraft in space that perhaps were either manufactured using regolith from the moon or were put into position in geo using water that we brought back from the moon and cracked. Those are true production economies. It's going to be a long time. This is the long view that Jack referred to before that's real. So in the middle is this infrastructure phase. And it's the point where you have enough infrastructure that's coming from, frankly, government investments by both the United States and I would say some, if we can keep them out of the critical path, as Jack pointed, international contribution, and you've got communications and power and data storage and data processing. That leverage can be used then to reduce the barrier of entry for commercial companies who just want to prospect and they want to find that product that Earthlings will pay for. So I think for the near future, the next decade, let's say, it's going to be heavily invested by the government to set up infrastructure with folks that can get commercial opportunities either on Orion, on the gateway itself, or on the surface that can make use of that and then find if there is that marketable product. Because that marketable product that Earthlings will pay for, that's what brings vast amounts of infrastructure and development into exploration. Before that, it's really the budgets of the space agencies with being as efficient as possible and privatizing the services where we can.
Right, I'm going to ask for my slides to come up, and I'll try and use them. You didn't use yours. That was good. If we look at the resources, and let's see, how do I go forward here? Let's try this. This is what I want. If we look at the resources, we've learned an awful lot from the samples and the data that Apollo brought back, but we've also learned a lot from the missions subsequent to that, some of which and most of which have been non-US. But there's Lunar Reconnaissance Orbiter was launched 2000 and forgotten the year now, so long ago. It's been up there a while. And we've got wonderful data sets, not only global data sets, but the same data over different time periods. We now know where to go on the surface, at least at the poles, to find water ice. But these, you could see, there's probably see those little points at the poles. They represent 280 meter by 280 meter pixels. They represent areas where the modeling shows there's up to 30% water ice at the surface. So, but the problem we've got is that they're very cold. So robotic prospecting becomes essential because we need the prospecting in order to look and find different water resources. They're not just at the poles on the moon, but water is the common thread between Mars and the moon now. And who'd have thought that during Apollo, after Apollo? I mean, we're now in that post-Apollo period, and now water is now the resource. So we need to sort of learn from what we can do on the moon. If we're going to set up infrastructure, let's not use the moon as a stepping stone, because we don't want to abandon that. That is just poor management. We need to leverage it, and that can become commercially viable. Trying to do that with station, and there's growing pains in doing anything new. So, but we've got synergies between Moon and Mars in terms of developing extraction, refining, storage, transport of cryogenics off planet. We can learn from the moon and then use that to leverage the commercial side of things. So I want to show this diagram more than anything. If we're going to stimulate commercial entities to go look and find, mine, sell the resources that we know are present on the moon, We've got to give them the data that will allow them to build a business case to see if they can actually do that. We've got to go prospecting. So you could see this, the text in the middle of those intersecting science, exploration, commerce slides. That's what NASA and other space agencies can provide by prospecting rovers on the lunar surface to go look at the composition, abundance. What are the properties of the regolith? We've not visited the poles, we don't know. There are other places to go as well. What are the environmental conditions? What's the distribution? How much of an ore body do I have? And is it renewable? We don't know that. So, and then you've got to get into extraction and so on and so forth. But those are the core data that are needed to actually give quantitative estimates of how much money we can get out of this. But again, we need to develop a market. So if you develop mining water, let's think about LOX hydrogen engines for our reusable landers to and from the gateway. So we've got to get, LOX hydrogen becomes important. Great to see that big liquid hydrogen tank on SLS. It's just a shame it's not reusable, just saying. But again, it's something that we can think about stimulating at this stage a potential future cislunar economy. Is that better? Cislunar economy, okay. So that's something that we could think about in terms of stimulating a new economic mining sector off planet. We've got lots of companies that are out there. You've got to start doing it. You've got to give them the data so they can do it.
I'm going to go into one more topic, which is related to what we've been talking about right now, and that is territorial claims by sovereign nations. World's currently facing complex situations of territorial claims by sovereign nations associated with establishing or expanding a permanent human presence to remote areas of the Earth, such as the polar regions. So could each of you touch briefly on how potential territorial claims by sovereign nations may impact the establishment of a permanent human presence on the moon? Looks like Harrison's ready to fire.
Yeah, just that, again, I would just mention the Outer Space Treaty of 1967. Signatories to that treaty have agreed that there will not be territorial claims. And that's why it's important to establish that claim regime that I mentioned. And I think the United States should immediately start to take the lead in doing that, at least with like-minded nations that are may have some long-term interest in lunar resources. Now, having a claim regime doesn't imply there's a territorial claim. It just means that you're going to manage the acquisition and utilization of lunar resources. The one resource that we have not mentioned that does have a potential economic value here on Earth is helium-3 as a fuel for fusion power reactors. The other resources that we're talking about really are resources that will be useful in space. The only one for which I think a case can be made that would provide an economic return to bring back to Earth is helium-3 fusion fuel. But the Outer Space Treaty of 1967 is the only operative legal regime that I think one needs to consider. There is the so-called Moon Agreement that theoretically has entered into force, but none of the major spacefaring nations have signed on to that treaty. And in fact, that agreement, that would stop any kind of human activity on the moon if it was implemented. It would just become impossible to get a full-fledged international agreement consensus on what we ought to do. If you think that treaty is a good idea, why don't you take a look at the United Nations and how it works?
So I'll have a little more optimistic view. I look at space station, and to be honest, if you even go back to Apollo-Soyuz or America's going to Mir, the space is always kind of transcended. Even I would posit, and we'll see if Jack agrees, although Apollo started and was no doubt a geopolitical driven program, when we landed, there was enormous support, not necessarily from all the governments of the world, but from people. When we talk about going off planet and moving humans out into the solar system, what the average person thinks is going to make a really big difference. When you look at space station and 124 countries now that have either contributed or flown experiments, that to me is an existence proof that when it comes to things that aren't involving various freedoms here on the earth and resources, and you're talking about something that's just outside our reach that we're all grasping for, that really brings people together. And so as a consequence, ISS that was sort of philosophical, ISS as an existence proof. Exploring the moon is just too damn hard without pooling resources. If you were to have two complete set of navigation systems at the moon, or two different sets of communications, or two different sets of power infrastructure, I think what folks are going to realize is they can very quickly, and if America leads by getting some of this out there, it's not America alone, but if we lead by getting that infrastructure out there, the international partners are going to want to participate or want to make use of those resources and not start over on themselves. And that, to me, will be, therefore, a sort of the self-correcting mechanism that will ultimately result in collaboration at the moon, simply because it's too expensive and too ridiculously hard to do by yourself with the kind of budgets that we actually have available to us today.
I'd just add to that with regards to American leadership. As a newly minted American, I take it personally when I'm in Europe or I'm in Japan and there's doubt about the path that we're on. I can understand that. So if we want to lead, we need to create some sort of permanent, semi-permanent infrastructure that will allow us to lead and gain credibility back. I'm not sure Gateway is the way to go, because that is not what I call permanent. If we want a permanent presence, I think we need to do it on the surface of the moon, and then use that as a learning facility for Mars, as a growth facility for private enterprise, for the resources that could then be used to go to and from Gateway. We practice that to then do that at Mars. The whole point of the moon is to enable us to go to Mars and keep going to Mars and maybe even stay there permanently. I just think that the moon is now at that point where it can do an awful lot of enabling with a cislunar economy, with jobs. I like my grads from Notre Dame to be able to say, when I asked them, what are you doing after graduation? I'm going to go work on the moon. I like my grandkids to be able to do that. And I think that's an important thing to have, that we're building something here that is beyond a presidential term. It is beyond a congressional term. It's out into the future that brings in that next generation that will allow us then to become a true spacefaring or multi-planetary body species, because of the things that we get started here now and we grow incrementally in an integrated way, with leading the world out into the solar system. And then I think we overcome some of the things that we're talking about with territorial claims or anything like that, because of the framework there's been a lot of thought put into that we can then work through. And I think, but we have to show leadership and stay the course.
Well, I think that about wraps it up. So let's give the panelists a round of applause.
We may have time for a couple of questions if anybody has one. Jeff, I missed you earlier. Do you want to be the first?
Jeff Faust, Space News. Just to follow up on that, what would need to change about the Gateway to make it a more effective piece of infrastructure for lunar exploration, telerobotics, or so on, in terms of its capabilities, its orbit? What would have to change?
What would have to change? Well, I think it needs to be up there for longer, number one. But in terms of the orbit, I mean, I've heard a number, and I'm looking forward to the discussion so I can learn more. Geologist, not an engineer, so I'll make that caveat now. But in terms of downmass to the surface, there's I believe, about a 50% reduction in going through the gateway than going direct. In terms of a safe haven, because of the orbit that the gateway is going to be in, if you're unlucky, you have to loiter about 3.5 days before you can actually find the gateway or get to the gateway. Well, you may as well just come home. So I think there are some things that the gateway that need to evolve, and I've noticed that it has evolved. But I think the one thing that is important about the gateway is that that infrastructure could be the thing that survives a change in administration. Having seen what happened with Constellation and before that, many other things. But this is something I think is, as far as I know, is an evolving architecture that can continue to evolve in order to increase capability. But again, it comes back to the point of why are we going forward to the moon? What is this for? All right, so then you've got a gateway because we don't know why we're going forward to the moon, so we don't know what its capability should be. So we need to articulate the reason why we're going forward to the moon in order then to maximize or optimize any orbital platform that is going to be in the vicinity.
I guess given the international situation that I've alluded to, I would say I would just convert the gateway funding to a lander program. If you don't, somebody else is going to be there and be pretty well established before we even think about a lander.
As the odd man out, I'm going to triple down, not just double down, but triple down on the gateway. So a couple of rebuttal items. One is if you're putting cargo down or putting down robots, yeah, don't go past the gateway. Don't go through the gateway. Direct is fine. When it becomes valuable is when you send humans. Humans going to the gateway, and then from there up and down with a reusable sortie-driven vehicle that can be fueled on orbit and go anywhere and come back. That opens up the whole, particularly from this orbit, opens up the entire surface of the moon. And reusability, in my mind, is sustainability. If we throw these spacecraft away every time, throw these landers away every time, versus all I need now is Orion to get out and I've got a reusable lander, that's a completely different paradigm. And it's really, really, really hard to create a lander that will just survive on its own for a year before we go back out again, right? So having the gateway as a spaceport is effective. And then the other is the solar electric propulsion, which is a big investment by the government, allows us to move the gateway anywhere. You can move it down to a 24-hour orbit, such that you're less than a day getting back to the gateway as a safe haven. And somewhere in there is a tipping point, right? Where it's now you can take more mission, not safety, but mission success risk, because you can get back to the gateway more quickly. So for all of those reasons, and then to Jack's point, I'm not convinced that the fastest, not the cheapest, but I'm not convinced that the fastest way to humans to the surface is direct. When you look as an engineer and you look at the systems complexity of interfacing, say, Orion with SLS in a commercial vehicle with a lander going out to, whether you rendezvous, on the way to the moon like we did with Apollo, or you rendezvous at the moon, that's more complex than we meet at the gateway, uncrewed with the lander, and the lander's only job when it's crewed is down to the surface and back up again. There's a reduction in the programmatic complexity associated with all those elements of interaction, the systems engineering, systems of systems, that if you don't have to bite that off, which you don't with the gateway, you then can, it's not going to be cheaper, but it'll be faster and lower schedule risk is my perspective.
Hi, I'm Irene Klotz with Aviation Week. If it's successful, what do you think the effect of China's upcoming landing on the far side of the moon and the follow-up sample return mission will be, and what do you think would be an appropriate, if any, U.S. response given the prohibitions on U.S.-Chinese space exploration cooperation? That's primarily for you, Dr. Schmitt, but anyone who'd like to answer.
Everything that I know, which isn't a lot, but it just trying to be an observer, is that the Chinese have a very systematic plan, and landing and sample return is part of that plan. And they have the capability, as the former administrator Mike Griffin has pointed out, to assemble lunar, human-capable lunar landers in Earth orbit, and also to move to landing on the moon. I would not. I think you just have to assume that their program has a very coherent long-term plan to begin to be the dominant spacefaring nation. Discussion we're having here does not include the Chinese as part of the international community. It would be nice if they were, but that is not apparently the plan that they have. So I would look at that landing as just part of a systematic approach. And if we don't recognize the challenge that they present for deep space activities and deep space competition, then I think we'll be making a very serious mistake that will affect us here on Earth, just as if we had not recognized the challenge that the former Soviet Union represented in deep space. It's just, I think that's the reality. That's the geopolitical reality today, and we're going to have to accept it. And what is hard for some of us from the Apollo era to recognize is why it's taking so damn long. If you decide to focus NASA's attention on this problem, or some agency's attention on this problem, I think we can move as rapidly as we did in Apollo, and I think we should. But right now, NASA is not focused on implementing a response to anything that is happening in the geopolitical realm. And until it does, I think we're going to be in serious trouble.
I just want to add on to that because I don't do politics, as I've probably shown here. But as a scientist, I think this is fantastic. I wish them all the best. I hope they succeed, and I hope the geopolitical folks over here take note of their capability that they're building. There's opportunities for scientists to analyze those samples that they're bringing back next year. But we have to go to China. They're not allowing them to come out of China. So we have to find a way to be able to be allowed to go to China to be able to work on them and analyze them with their facilities. You can't use NASA grant money for that because you go to jail. I don't want to do that. So you can talk to the Chinese. So you've got the International Space Exploration Coordination Group of 15 space agencies. In a multilateral sense, there's dialogue going on. In terms of a scientist to scientist, I know that there is dialogue going on at a much lower level in terms of cooperation to get data from them. And I've got Chang'e 3 data from the U2 rover. Had scientists come over and visit me. So there is cooperation at that lower level. But at the higher level, geopolitical level, if I was involved, I'd screw it up. And man knows his limitations. But I think it's important that we keep asking the questions as to what is the response? What is, how are we going to address this? If we want to lead, we need to do something to lead rather than play catch-up. Don't want to play catch-up.
But
Let me just add one thing. The commercial sector, Blue Origin, SpaceX, and others are providing some response because, for example, the Blue Moon lander is under development. That's a fairly large piece of equipment, I think, and there's going to be, in not too distant future, I think, an announcement of opportunity out of Blue Moon, maybe at the league meeting, I hope. So there are responses, but right now those responses are primarily in the private sector.
again, let's thank the panel, and I believe we're scheduled for a break.